you still remember this part, alright, this is the very critical part of talking about the visualization of the graph itself. And in this video I'll just talk about something that is more critical in the sense that it defines our terms better. Alright, do you see that there is an input and an output and a new input and a new output, if you still remember? In fact, we can actually name these two terms pass information, right? Because this is the pass input and the pass output, and and therefore this new input, I will call this the current input. Alright, or in other words, the input now, what I input now, plus what I have in the past will give you my current output. Some sort of that meaning, if that's make the case. Alright, I hope that this is pretty clear. Alright, based on the previous video, hope that you still remember. In the video previously, we also state that this graph, alright, we have K1, K2, K3 and K4. Right? While this new input, alright, only contains K2, K3 and K4. So what does this mean? This new input contains less information than this, because this old input has a information on K1, or this new input has a lesser information. Alright, so what does this do? Well, actually I should better represent in the current state, alright, that K1, K2, K3 is this one, alright, to be more exact. And then plus this K4, sorry, yeah, it's over here. So this graph over here is one time step, alright, one time step more, because it has one more input, and therefore the next round it goes by, it will generate K4, right? It generates K4 as, okay, for example, K3 input into this system, correct, and output into K3 over here, into the output of K3, alright, into here, and this thing will feed back into K3 plus 1, which is K4. Alright, so this K4 will become the new input. Alright, this K4 will actually interact with somewhat another, your current input, I would say. So interactions between your feedback, or in other words, your feedback right now is the information that contains in here. Alright, while the new current input is K4. So it's something like you are plotting. So the feedback system is in fact this one. Alright, this is the feedback system plus the new input, which is plus adding this one over here. Okay, so therefore this graph will have a one time step more than the previous input, some sort of the meaning. I hope this is pretty clear right now, better understanding, I would say. This one time step move, more, we can also call this one time step delay. Alright, or one time shift delay, because it delay by one time shift, something of that meaning. Take back my words. Alright, this O input should be the one delay compared to here. Alright, so this O input, it should be the one time shift delay that applies into here. But however, this input plus, alright, if you look at this is plus, the new input, alright, we know that this input, alright, this input and the output system will feedback over here. Alright, will feedback into here, plus the feedback will give you a full understanding on the new output that is gonna go through here and come out from here. And this will be your new output. Okay, so far so good. So therefore this input is one time shift delay than this one, because you have a new feedback system that is going on within that. So beforehand, before you go to PID, because PID will be a second order system, there will be a second order system, and therefore there will be some sort of a graph, something like that, and this is K5. Alright, so there will be a K5, so there will be an O input of K3, while at the output, at the so-called interactions between the new input, alright, we'll have a K4 and a K5 within it. So the new input within itself has information on K4 and K5 together. So therefore this one will mix with the feedback system over here. So this one will feedback with a second order input which is using K4 and K5, then they will give you a new output through this transfer function out, and we will have a new output graph of K4 and K5. And please note that this graph is different from this. This output and this new output and this output is 2 shift delay. Alright, output and output are in terms of delay difference, but their graph are the same. For example, the new output will be something like this. The old output will be something like this only. Alright, so it's somewhat delayed by a certain time before it reaches the new one somewhere over here. Alright, but this output and the input graph will be totally different two things. Alright, so the input may have something like this for the O input, while the new input will have a one-time step forward than the O one, something like this. So actually this one from here onwards is new input, behind is the O input, something of that meaning. So if the second order is 2 shift, means you have 2 variables or 2 time step. If it's third order system, then you got more time step and things like that. I shall see you in the next video.